Good afternoon and welcome back to the History and Philosophy of Science in 6 Easy Steps. I hope you enjoyed week 2. I know I enjoyed reading your posts and your essays, and of course I always enjoy talking about Thomas Kuhn. He's one of my favorite philosophers and thinking about him. So I want to do a couple things right now, just real quick. I want to recap week 2, and then I want to give you an introduction to week 3 and Karl Popper and the assignments we'll be doing for week 3. All right, so week 2 first started off with watching a video, or a couple of videos, which were a play about the discovery of oxygen. I know the play is a little bit dry at times, and maybe I may or may not use it next year. I'm not sure. I've got to still consider that. If you have any feedback on that for me, please send it my way, because I'd like to know what you think. I already got feedback from a couple people on the play, but it did, I think, do a good job, a fairly good job, of explaining the whole process of the discovery of oxygen and the contributions of the 3 men that were involved. And I think many of you, or most of you, got the basic idea of it, and that was that there's kind of three aspects of discovery that are brought out in that play. One is the first one to actually produce a relatively pure sample of oxygen was different than the first one to publish that he had produced it. And those were both different from the person who had been the first to understand it in what we consider a more accurate way. So a lot of people might credit Lavoisier with the discovery because they might say that, well, the other two produced the stuff, but they didn't really make it. And in fact, Thomas Kuhn seems to kind of lean in this direction, because he mentions, for example, with X-rays, that other people may have seen the effects of X-rays and never noticed it as being anything significant. And so can you say that they discovered it? If somebody, the first one to see a new species of insect, for example, on a tree, do they count as the discoverer? I mean, so those are questions, those types of questions some of you raised, and I'm not saying I have the answer. I kind of like the way the movie just kind of left it. They didn't really answer the question, but these are good questions. And I think what I like most, the answer I like most is that there's like 2 options. One is that discovery involves some combination of all 3. So you kind of have to have all 3 in some combination, but maybe not with the publishing. Publishing might not be important, and some of you brought that out. But there's another option, and that is that maybe this whole concept of discovery is kind of bogus. I mean, nobody really discovers in a vacuum. Nobody is the sole person responsible. As Isaac Newton said, if I see farther, it's because I stand on the shoulders of giants. And so he was recognizing that he stood on the shoulders of Galileo and Copernicus and others that had come before him. And so I'm not sure, the idea of issuing prizes to people for discovery is kind of questionable. Not that certain people don't contribute more, maybe, and deserve more credit. I don't know, but I'm kind of getting off track here. So anyway, there's still some open questions about this. But one of the things I like about the movie is that because they bring in this kind of modern Nobel Prize team, they also kind of show that these sorts of things are still issues in modern science today. These kind of political things that go on between scientists wanting to be the ones who are seen as having discovered something. So still goes on today. All right, the other thing interesting in the play is it's kind of questioning about or bringing up the questions about the roles of women in that time and even in modern times, and how women are seen in the scientific enterprise. Also, the role of historians in this process. And that's kind of interesting in the context of our course, isn't it? Okay, so let's take a look at the next part of the week 2 assignment, which was a Thomas Kuhn essay. And I hope you got a chance to watch the video if you needed it, if you needed help reading through. I know the readings are kind of tough. And you're going to get a chance, if you still don't feel like you have a good grasp at Kuhn, you're going to get a chance in week 3, because we're going to end up comparing him with Karl Popper, who's the next person that we're going to be looking at. So I want to actually read from one of your own essays to kind of sum up Thomas Kuhn. And so let's just do that. I'm not going to read the whole essay, but I want to just make some highlights. So this is one of your classmates. I was pretty impressed with their grasp in this case of Thomas Kuhn. And by the way, I think that everyone I've read so far seemed to get the gist of it. There might have been some confusion here or there. So that's why I want to do this, is to clear it up. First of all, I like this first sentence because it kind of raises an interesting question. One could hardly doubt that the progress and development of science has had an enormous impact on society. The interesting thing is that some people do doubt that. And the way that they do that is they make a distinction between science and technology. And they say that they're not the same thing, and that it's really technology that's had an enormous impact on society, not necessarily science. And that's something we're going to visit in week 4, this question of what is the relationship between science and technology. Okay, and is science really necessary for technology? But let's leave that for now. I want to read this summary because I think it's pretty good. Some would say that science is a gradual accumulation of knowledge built up bit by bit over the years. However, philosopher Thomas Kuhn argues that science cannot be considered steady accumulation, but instead is a series of complete changes in worldview. He calls these paradigm shifts, when scientists' worldview in a particular field undergoes a drastic change, the old paradigm found to be inaccurate, a new one that better reflects the data, replacing it. Okay, so the basic idea is in that last sentence. A paradigm shift is when a worldview undergoes a drastic change. The old way of seeing things is found to be inaccurate and unusable. Okay, and this is actually true. Even, some people say, for example, that Einsteinian relativity and relativistic physics is kind of encompasses or includes Newtonian physics, which came before it. But Thomas Kuhn, I think, makes a pretty good argument that that's not the case, that Newtonian physics is not correct. It's not a really accurate picture of the universe. It's an approximation, and it's a very good approximation in many cases. But that Einsteinian physics actually replaces it. And those two views of the universe are actually not compatible. And now maybe you could disagree with him, and I'm sure there are people who disagree with him on that. But anyway, it's a total replacement. I think it's much more obvious with phlogiston. So phlogiston was a pretty comprehensive picture of the world and of chemistry, and it was totally replaced by Lavoisier's system, by his system of the oxygen theory of combustion. Totally replaced. There's no longer any use for the phlogiston concept. So in what sense can we say that Lavoisier built on phlogiston and built on that theory? It's like saying you built on a foundation when you totally demolished that foundation and built a new one. Now, there is one sense that we could say they build on one another, and there may be more, but this student kind of brought that out. And they said, while most of Kuhn's theory is sound, there's one aspect with which I do not entirely agree. Science still builds off itself, even if the old paradigms are discarded. As stated above, normal science under one paradigm allows a new paradigm to be created. One could argue that new science is built off the old paradigm, even if it contradicts the old theories. In this, science can be compared to a tree. As it grows, the lower branches die off, replaced by new branches. But without the energy provided by the leaves on the old branches, the new branches never could have been created. Now, and this student goes on to say that that Kuhn kind of would not agree that it's like a tree. And I'm not entirely sure about that, but I do like this analogy, and Kuhn does talk about it. In fact, he talks about the fact that, and this student mentioned it earlier, he talks about the fact that normal science which we're in right now, by the way. We are in a period of normal science right now in most fields. Normal science is very good at generating anomalies, which end up leading to its own demise. So any paradigm, once it's established, what happens is all these scientists start working in that paradigm, coming up with more and more and more data and exploring and trying to apply that theory to more and more areas. And what happens is you start to generate anomalies. And eventually those anomalies lead to the demise of the science itself. So in this way, you could say that each paradigm is definitely contributing in some way to the progress of science, which leads us to that final question of how does science progress. And this student says, in conclusion, Kuhn's theory of paradigm shifts explains the process of scientific understanding very well, while the progress of scientific research remains cumulative. Science can be considered a combination of both research and understanding, meaning that scientific progress is both cumulative and a series of paradigm shifts. I like this compromise. It's not entirely clear here, but I like the implication that you could say that there is both a cumulative and kind of a paradigm shift type nature to science, where we're kind of still progressing. And I think another way of looking at this is think about it like this: what if each new worldview is actually more powerful, more broadly applicable, more accurate in some sense, more precise? And I think that this might be true. For example, Einstein's theory of relativity can do everything that previous theory could do, but it can also do more. Quantum mechanics can do everything that classical physics could do, plus more. Okay, so I think that is true to some extent at least. And maybe that's our answer, that what we're getting is these totally radical changes in worldview, and that each one is better than the last, at least in some sense. And at least we can hope for that. Okay, so that's a recap of week 2. Let's take a little preview of week 3, shall we? So, by the way, duck or rabbit, what do you think? Week 3, the Tao of Science, or the Way of Science. This week we'll be taking an in-depth look at the powerful way of looking at the world called science. What is it and how does it work? And this week's assignment has 3 parts. You need to start by doing the reading first of all. And I also have an audio version. It's actually, I believe, a YouTube video with somebody reading Karl Popper's essay. You got to start by doing that reading. Very important. You got to understand his perspective. I'm going to give you a brief overview, but you got to have an in-depth understanding. And then for part 1, what you're going to do is write a position paper like we have been on your choice of a questionable science. I said pseudoscience here. I threw in a couple that many might consider sciences or may not, and I'm not going to show my cards here. What I want you to do is describe whether or not, or explain whether or not this thing is a science or not, and include Popper's view as well as your own. And if you agree with him, that's fine. You can say that. Remember, when you're writing these essays, to include other points of view. And if you want, take a look at the example essay I put up last week. Okay, so the second part, you'll be comparing Popper to Kuhn, and instead of making an essay for this one, we're changing it up a bit, you're going to make an infographic or other visual summary of the comparison. What is an infographic? Well, we can find a whole bunch of examples. I didn't want to put an example up here because I didn't want to scare you. A lot of these are very complicated, and yours doesn't have to be. And I put a link to a site that looks like it makes it very easy. It's got some nice templates. In fact, it's got a nice comparison template up there that you can probably use. So infographics are just ways of showing data in an interesting way, and here's a whole bunch of examples. So there's a lot of different types of infographics. A lot of these are very complicated, but you're just going to make a simple one comparing Thomas Kuhn's views to Karl Popper. Now, I'm not implying that they were necessarily talking about exactly the same things, but that's kind of what I'm looking for here. Where were there areas of overlap? Where might they have disagreed? Where were they not even addressing the same issues? And then for part 3, you're going to post either going to post your infographic, say on the forum, or post a link to it, say on Twitter, and we're going to discuss. And I forgot an important thing. On the first part, the part 1 assignment about pseudoscience, I want you to, instead of posting it, instead of just sharing it on Twitter or just posting it under the assignment, I want you to post it also on the forum, and then I want you to respond to someone else's. So this is something new. We're changing this up a little bit. I'm trying to make this a little bit more interactive this week. And so what I want you to do is, after you've done your essay, so pick one of these options. You can choose your own, just get my approval, and then post your essay on the forum or post a link to it on Twitter. Then respond to someone else's essays with a brief reply. Remember to keep it positive but significant. So say something significant. If you're going to agree with them, then explain exactly why you agree. And if you're going to critique them, just make sure it's positive and make sure it's significant. It's not about spelling or grammar or something like that. All right, and I added a line for the response onto the rubric. So to wrap up this week's intro video, I just want to talk a little bit about Karl Popper. Very influential philosopher of science, probably second only to Thomas Kuhn, if he is even second to Thomas Kuhn. And he came up with this concept of science as falsification. And he's got this, one of his most famous lectures is called Conjectures and Refutations. And I think you'll find this interesting. When we try to define science, and you guys have all taken lots of science in school at this point, by the time you reach high school, and you've heard of the scientific method and the steps, how there's supposedly all these steps and stuff like that. You might have even heard definitions of science. This, I think, is going to be interesting for you to hear a philosopher of science actually kind of lay out his reasoning for a definition of science. And you're not required to agree with him here. Nothing about this course is like that. This course is about questioning things, being critical, being thoughtful, and citing your evidence and explaining your reasoning. And so that's what I want you to do, is listen to this, read it, and then do a good job, do your homework on these various practices here that may or may not be science. The reason I said if you choose your own, get my approval, because I don't want you to pick something like physics, which is obviously a science. So I want you to pick something that's at least questionable by some people, or questioned by some people as to whether it's a science. So this idea of falsification is what you're going to be reading about. And I guess the one thing I will say as you're reading this is that there are some things in Popper's views that I do question. And also, while you're reading or listening to it, I want you to be thinking about how he compares to Thomas Kuhn, and whether, like if the two of them were to sit down and talk, whether they would agree with each other or not. And so, be thinking about that while you're going through this. Just a real quick preview of some of the things to come. If you look ahead into week 4, I'm still kind of tweaking it, so don't jump ahead too far. But week 4 is going to be lots of fun. We're going to start to talk about kind of the connection between science and history, in the sense of what might have caused the scientific revolution. We're going to be looking at some cool articles and videos on this, and asking about something called the European miracle. All right, so it's going to get a little bit, possibly a little bit more interesting, a little bit more historical, more like week 1. And then after that, we're going to go into the influence of science on society. And here, I'm still playing around with this, but we're probably going to talk about science and technology, and we're going to talk about the scientific worldview itself. It's interesting that science itself and the scientific revolution itself was kind of a giant paradigm shift. for much of society. And so we're going to get into that in week 4. And then week 5 is very exciting when we talk about the singularity. All right, close with just a little bit of a reminder, encouragement not to procrastinate on these. There are no zeros in this class when all is said and done, because if you haven't completed everything with at least 60%, then you simply won't get credit for the course. So please do try to stay on top of these assignments, and remember that you can always resubmit for a better grade, and remember that you can always contact me with questions. All right, and I hope you have fun with this on week 3 with Karl Popper. And thank you for your hard work in this course.